Okay, thank you very much. Good morning. I am John Olansen, and I'm the production manager for the Gateway program, where I'm responsible for the design, development, and delivery of the Habitation and Logistics Outpost module, as well as the co-manifested launch of that module and the Power and Propulsion Element, in addition to some other complex project development activities, including the autonomous software that will control the Gateway stack. Today, I'll be providing you a brief overview of the Gateway program, in which I'll highlight several significant areas of work that are currently underway. To begin, I'll talk in relation to the Artemis program that we see on slide 2 of the slide deck. So yesterday, Administrator Bridenstine talked much about the Artemis program, and he touched on the importance of Gateway within that program. As the graphic depicts, there are a series of flights we're pursuing as an agency under the Artemis umbrella that lead to landing humans on the moon again in the next few years. There are unmanned science missions through the CLIPS program, test flights of SLS and Orion leading to crewed missions, and development and deployment of the human landing system. In the middle of those launches is the first launch of Gateway elements that joins this grand expedition. The Gateway is a fundamental focus of the pursuit to create and maintain a sustained human-capable presence in cislunar space. On slide 3, we talk more specifically about how NASA and our partners will develop the Gateway under the Artemis program. Together with our international and industry partners, we will establish a sustained human presence on and around the moon over the next several years. The Gateway is a vital component of that program, establishing that architecture to maintain that sustained presence, providing long-term human return to the lunar surface. Gateway will remain in lunar orbit and continually maintain that access to the lunar surface while enabling us to test and evaluate ways of doing business that can be used for future exploration, including sending the first humans to Mars in the coming years. In all of that, Gateway plays a vital and pivotal role. As we go forth in developing the Gateway, we're embracing innovation and flexibility both in how we establish the architecture, as well as how we work through procurement processes and implement our development approaches. On slide 4, we talked about the first elements of the Gateway that are to be launched. We're working hard right now towards the launch of both the Power and Propulsion Element that's being built by Maxar and the Habitation and Logistics Outpost that's being built by Northrop Grumman, and that will be integrated into a single launch in late 2023. The PPE is the engine, the lifeblood of the Gateway, providing propulsion and power to the station and communication back to Earth. Halo is the nexus of the Gateway, serving as the hub where Orion, landers, logistics vehicles, and future Gateway elements will be able to aggregate. It is the first habitable module that will also serve as the command and control backbone for the Gateway. In addition, ESA is providing the lunar communications capability that will be integrated within Halo. Our other 2 esteemed panelists today will discuss these elements in more detail in just a few moments. Moving to slide 5, I'll talk about the Gateway Logistics Service and mention that on March 27th this year, NASA selected SpaceX as the first U.S. commercial provider under a Gateway Logistics contract. That contract mechanism is established to deliver cargo, experiments, and other supplies up to Gateway. We are planning multiple supply missions in which the cargo spacecraft will end up staying at the Gateway for 6 to 12 months at a time. In this instance, SpaceX will be delivering critical pressurized and unpressurized cargo, science experiments, and supplies to the Gateway, things such as sample collection materials and other items the crew may need on the Gateway and during their expeditions on the lunar surface. On slide 6, we touch on EVA. Walking on the surface of the moon requires the astronauts to wear a specially designed spacesuit, what we call the Exploration Extravehicular Mobility Unit, or XEMU, to protect against the harsh lunar environment and to enable exploration. That new XEMU spacesuit is designed to be worn on the moon or any other planetary surface, and it will provide enhanced mobility for walking and kneeling. The spacesuit connects to the landers for recharging between moonwalks and can be resized to fit each astronaut. Testing of the first suit will occur on the International Space Station in 2023, with the first units built in-house for 2024 lunar mission, and then contracted from there. Going to slide 7, since the Gateway will not be continuously occupied like the ISS, NASA envisions crew visits approximately once a year. And so a strong focus is placed on robotic integration and data systems that can foster ongoing investigations and operations that can operate autonomously between crew visits. Gateway is being designed really to support a number of different and a variety of different utilization activities, and they'll be operational both during crewed and uncrewed periods of time. Back on March 12th, NASA announced the first 2 science payloads that will launch and be active on Gateway. There's a radiation instrument package from ESA, and there's a space weather instrument suite from NASA, both which will be launched again with the first launch of Gateway. And lastly, on slide 8, again, as the administrator stated yesterday, the Gateway will be constructed with the help of international partners. And that will occur much like the International Space Station, which has been operational for 20 years and serves as a model of international cooperation. He talked yesterday about agreements with ESA and JAXA and CSA, and we are working with them routinely to accomplish our objectives. Now, with that very brief overview and number of charts, because I really like the graphics, I will yield the mic to Vince Bilardo to give you more information specifically about the power and propulsion element. Vince?
Thank you, John, and good morning. My name is Vince Bilardo. I'm the Senior Executive Program Director at Maxar Space Infrastructure, formerly Space Systems Loral, located in Palo Alto, California. You see there on this opening chart a great image of the business end of the power and propulsion element with 48 kilowatts of electric propulsion thrusters powering the co-manifested vehicle from our drop-off point up to the near rectilinear halo orbit around the moon. I want to talk a little bit more about the technology and the technological advances that we are pushing to make and design into and fly in the power and propulsion element. If you can go to the second slide, please. The PPE, as we call it, is exactly that. It is an element that on the right side of this slide is built on our Heritage 1300 series bus, which has flown, is currently flying over 90 active missions in space, primarily as a bus for geosynchronous communication satellites. So we have a rich, well-proven heritage associated with the 1300 series bus that we are leveraging to increase the power capability and the electric propulsion capability. The left side of this chart indicates an evolution that we have been working to propel at Maxar in both of these capabilities, both the solar array technology in terms of power generation to the bus and voltage, as well as power processing electronics and Hall effect thrusters. We are currently in the second generation of solar electric propulsion, where we have over 15 of these buses that have flown an electric orbit raising. In other words, a spiral out from the drop-off point or the injection point off the launch vehicle into the intended ultimate orbit. And what we seek to do in the PPE program is create the third generation of power and propulsion capability with the rollout solar array, 2 of which will provide up to 60 kilowatts of power into the spacecraft bus, which will be unprecedented for any vehicle flying in space today other than the International Space Station. And power processing electronics to power Hall thrusters that will be operating between 6 and 12 kilowatts. Again, unprecedented Hall effect ion propulsion for electric orbit raising, station keeping, and attitude control once we reach the NRHO orbit about the moon. If you can go to the next chart. Very quickly, here's a snapshot of the current status of the PPE program, which was awarded in May of 2019. So we're a little over a year into the program, and you can see the milestones that we have both achieved as well as what lays in front of us over the balance of the next year or so. And in short, we are a program that constitutes a public-private partnership with our partner, NASA Glenn Research Center. And as such, we get paid when we accomplish predefined milestones. And so a little over a year into the program, we're about a quarter of the value of the program accomplished per the milestone payment plan. And key to this early stage in the program for how we do business at Maxar with the 1300 series Heritage bus is we have placed over 90% of our key subcontracted subsystem and unit hardware with a total subcontracted value on order now just over $100 million. So we are well into the program, even though we're still driving towards our initial preliminary design review. And of course, we're working closely with our partners at Northrop Grumman, NASA Glenn Research Center, the Halo production office that John leads, and the Gateway program to co-manifest the PPE with the Halo module and allow and enable a successful launch, deployment, electric orbit raising, and insertion into the deep space lunar orbit. And if we can go to the final chart, there you should see a nice animation playing of all of the first motion deployments after we're dropped off by the heavy launch vehicle. Here are the ROSA rollout solar arrays deploying. These are what we call DSMs with our 6 kilowatt Hall effect thrusters deploying. Here are the 12 kilowatt thrusters deploying that Aerojet will be providing to us. And here are all of the steerable high gain antennas, both a direct to Earth as well as lunar Ka band capability. And so shortly after we're an hour or two into orbit, that's what the co-manifested vehicle should look like when we launch it here in just a few years. And so with that, I'll turn it over to my partner, Dave Oberg at Northrop Grumman.
All right, thank you. I'm Dave Oberg. I have to say that Vince's video is a tough act to follow, so I'll keep it brief, and I appreciate the opportunity to talk about Halo and our status on Halo. I also have to appreciate the fact that John spelled out the acronym, so I don't have to worry about that. But as John said, Halo is really the hub of Gateway. It provides the 3 docking ports for visiting vehicles and provides the backbone to interface across those visiting vehicles and throughout the Gateway. We provide the crew operational spaces, the light support, the air circulation, the power, the thermal control, and also an important part of it, as John pointed out, is the robotics interface to enable long-term sustaining operations. I think we'll go to the next chart.
So Halo is derived from our Cygnus spacecraft. Excuse me. Cygnus has been very successful. It's really been a workhorse for us. We're getting prepared to launch what I believe is the 14th Cygnus not too long from now. I think obviously Cygnus is the mission, is the spacecraft that supports the mission to provide the cargo up to the International Space Station. So we have a lot in common from Cygnus to Halo. I view it really as the infrastructure that we carried from Cygnus into Halo. Our mechanical structure derives directly from our Cygnus structure. And our avionics architecture, and particularly the software architecture, the fault management architecture, the overall avionics architecture comes directly from Cygnus. Further, the way we run the program, many of our processes we carry straight over from Cygnus and apply those lessons learned so that we can take the very successful Cygnus program and enable a very successful Halo program. But I also have to point out that there are quite a few capabilities that Halo brings that go well above and beyond Cygnus. And it really comes down to the nature of Cygnus being a visiting vehicle at the space station, while Halo is the hub of Gateway. And so while astronauts will periodically enter Cygnus, astronauts will live in Halo. And so we offer quite a few more capabilities in that regard. And also to add on to a point that John made, yeah, we're quite proud about the fact that Halo really represents the first habitable destination for humans beyond low Earth orbit. And if we can jump to the third chart I've got, it occurred to me that if I was in the audience, I would want to see a picture like this. I would want to see what's Halo all about. So a little bit of reference points. The length is approximately 7 meters. The diameter is approximately 3 meters. As you look at the picture, the interface to PPE is off to the right, while the docking port to the left is available for visiting vehicles. I'll also point out that the image is a bit misleading. It could leave the impression that the entire area is filled with components, and that's really just an artifact of trying to show a picture in 2 dimensions. Certainly the majority of the interior cavity is available for astronaut use. I also want to point out that we're in the preliminary phase, and so this is still changing, and what we launch almost certainly won't look just like this. As far as the status, our status is very similar to what Vince described for PPE, although not quite as far along. We're also in the preliminary design phase, having finished our SDR and proceeding towards PDR. We also have numerous long lead hardware items on orbit, although not quite as much as Vince described for PPE. So overall, we view Halo as a very exciting opportunity. It's exciting for me personally, for our company, for our industry, and I really think for the entire world. And so we're excited to go forwards with it. And with that, I think we're ready for questions.
Okay, excellent. Thank you. So, hi everyone, I'm Jim Way. I'm Executive Director of the American Astronautical Society, your host for this event. It's early, people still getting up to speed, so we have one audience question currently. When does NASA plan to procure the launch for PPE Halo?
Thanks, Jim. This is John. I'll take that one. So we actually are already in the procurement timeline for that launch vehicle. So really in that window where we can't talk a whole lot about it, but it's underway as we speak.
Okay, great. Another couple of quick questions. So let's see. Always kind of the elephant in the room, budget status. What are we looking at as far as status for this initiative, and are we on target?
So I know the administrator talked quite a bit about budget yesterday and securing funding. So I'm not going to touch on any of that side of it. From an execution perspective, Maxar and Northrop, as you heard both Vince and Dave talk, are performing extremely well, making progress in what we need to do with these modules from an overall budget perspective. We've laid out what we believe is appropriate budget forecast, and I think we're in pretty good shape actually as we're executing at this stage of the development progress. And Vince or Dave, I'm not sure if you guys want to address that from your perspective.
Well, let's see. I think what's relevant for PPE is that our contract is funded through a number of contract line items, and exercising each one constitutes an option for NASA. We are currently in CLIN 1. It extends through just past the end of our preliminary design review. And at that time, NASA has the option to exercise and award us CLIN 2 or move on if that were to be the case. Obviously, we hope that's not the case. We're working hard to make sure that it isn't. But so we are fully funded through CLIN 1 at this time. And so that gives us a clear ramp to complete our preliminary design review and posture ourselves for NASA to exercise the option to allow us to move into CLIN 2, which would take us all the way through spacecraft build and to the point of handover to NASA just prior to integration with the HALO module at Kennedy Space Center.
Yeah, and this is Dave. I would add for HALO, the situation is very similar in that we are fully funded all the way up through PDR. However, where it's a bit different, we're negotiating the subsequent contract phases sequentially so that we can best reflect within our contract structure the nature of Gateway and Artemis at that point.
Okay, great. I do have a couple more, and my prompt got people putting questions in the Q&A tool, which is great. This is actually from one of our sponsors, Moog, Steve Witkowski. What is the current power level being transferred from PPE to HALO? And what's the voltage that is being transferred at? Pretty technical question.
Vince, why don't you go ahead and take that one?
Sure. So we are set up to have two 16 kilowatt power interfaces between PPE and HALO. So when we are not firing our electric propulsion thrusters, which would require the majority of the 60 kilowatt bus power coming in from the ROSA arrays, up to 32 kilowatts is then available for transfer to HALO and ultimately the rest of the gateway as we build it up over time. And that will be transferred at 120 volts via a step-up voltage converter from our legacy or heritage 100 volt 1300 series bus level to the 120 volts that HALO and the balance of Gateway wants to operate at.
Yeah, and I'll jump in and add that while PPE provides that substantial amount of power to HALO, a large fraction of that gets passed along through HALO onto other visiting vehicles. The actual amount of it consumed by HALO is a smaller fraction, still in development, but it's less than 10 kilowatts.
Okay, and I think we got time for maybe one, maybe two more. This one's from a friend of AAS, Darryl Shuck. Is the communications infrastructure defined, or is that still something being developed? For example, will DSN or TDRS be used? Are commercial antennas being considered?
So the communication infrastructure is still being defined. We have an architecture established that from a concept of operations perspective that will use Deep Space Network as we orbit the moon. And so that's where that's what we expect to do from a utilization perspective there. There's still a potential evaluation for different use as we go forward, I'm sure, but as we're designing the systems, we're expecting to use that Deep Space Network.
Okay, so let's just do one more question. It's 11:30. So let's see. Given that Gateway is at NRHO around Range Point, can you comment on how it's going to be used to support lunar ops? Astronauts are stopping there on the way to the moon, correct? That's how the Gateway is going to function overall?
Correct, yes. And that's a Halo orbit. There are multiple different types of orbits we could end up selecting. Chose a Halo orbit because it does provide that proximity to the lunar surface and access really all around the lunar surface. So it provides that capability. Gateway will again serve as that point where a lander system, logistics vehicles, and the Orion capsule can aggregate. You can bring everything together, establish what you need specifically for your mission to the surface, and get the crew down to the surface, and back up to Gateway before returning home. And that whole architecture can be established in a much more sustainable and reusable way that over time will save us resources that we need to really maximize our exploration of the lunar surface.